Good evening, Safila.
Good evening, sir.
Yes. How is the test paper? Or how is your test? How much you have attempted?
In the previous test,
Yes.
I guess I left one or two.
Okay. So let's discuss that question paper. Okay.
Okay, sir.
Is my screen visible to you?
Yes, sir.
Okay. First question is, a simple harmonic motion is described by A is equals to minus of 16 times of X. So what is the time period of this? According to formula, acceleration is equals to minus of omega square X. So if you compare these two equations, so coefficient of X will be omega square. So on comparing, you will get 16 as omega square. So omega will be root under 16, that will be 4. And omega is also equals to 2 pi by t. So you will get t is equals to 2 pi by 4, that is pi by 2 seconds. Is it clear?
Yes, sir.
Question number 2. Find displacement of simple harmonic oscillator at which potential energy is half of its maximum energy. According to the relation, potential energy is half of maximum energy. Maximum energy we have is half m omega square a square. According to expression, potential energy is half m omega square times x square. It will become half times half m omega square a square. So half m omega square will cancel out from either side. So you're left with x square is equals to a square by 2. So taking root, x will be plus minus a by root 2. It means at this displacement, potential energy will be half of its maximum energy or total energy. Any doubt?
No, sir.
Third question, the frequency of tuning fork A and B is 250 and 255 hertz respectively. Both are sounded together. How many beats will be heard in 5 seconds? According to formula, beat frequency is difference of frequency of two wave. It means it will be F2 minus F1. Beat frequency is also equals to number of beats produced divided by time taken. And F2 we have 255 minus 250. We have to calculate number of beats produced. So this difference will be 5, and time in which we have to calculate is also 5. So it will get multiplied with this part. So in total, you get 25 beats produced in 5 seconds. Is it clear?
Yes, sir.
Next is question number 4. A plane progressive wave y is equals to 2 times of cos. You may write 6.28 as 2 pi and move it to inside of bracket. So you'll get 2 pi multiplied by 330 into t minus 2 pi multiplied by x. Now we have to calculate time period of wave. For this part, take coefficient of t, which is nothing but omega. And omega we have 2 pi into 330 radian per second. So it will be equals to 2 pi by t. 2 pi will cancel out. So time period will be 1 by 330 seconds. Safullah, is it clear?
Yes, sir.
Next is question number 5. if phase difference between two sounds of wavelength lambda is 60 degree, phase difference is phi is 60 degree. You may convert 60 degree as pi by 3 in terms of radian. According to the formula, phase difference is equals to 2 pi by lambda multiplied by part difference delta x. So in this part, we have to calculate delta x. So according to expression, delta x will be equals to phase difference, which is pi by 3 multiplied by lambda divided by 2 pi. Pi cancel out. So you're left with lambda by 6 as part difference for phase difference of pi by 3. Is it clear?
Yes, sir.
Next, question number 6 and 7 is assertion based question. First assertion is, when a simple pendulum is made to oscillate on the surface of moon, time period increases. As we know, size of moon is smaller as compared to Earth. So gravity of moon will be 1/6 of that of gravity of Earth. And as gravity decreases, time period increases. So it is correct relation. Second, moon is much smaller as compared to Earth. So it is also correct. Due to this decrease in size, gravity is small, and that's why time period increases. So both assertion and reason are correct. And we can say reason is correct explanation as of assertion. So it will be option A. Saifullah, is it clear?
Yes, sir.
Second part, particle velocity depends upon time. According to formula, particle velocity is equals to omega times A cos omega t minus of kx. So we can say it depends upon time as well as position, both. For progression of wave, medium must have property of elasticity as well as inertia. I define you property of medium for propagation of mechanical wave. It should be elastic, it should be inertial, and it should offer least opposition. So these are different property of medium for propagation of mechanical wave. So in this part, we can say both assertion and reason is true, but reason is not the correct explanation to the particle velocity or dependency with time. So we can say both are true, but reason is not correct explanation. So it will be option B. Is it clear?
Sir, can you say how assertion is true again?
According to the formula, particle velocity is omega A cos omega t. So we can say it is time dependent function.
But it is also a displacement dependent
Yeah,
function,
both.
right? So it should be time and displacement.
It has written only one part. We may say its velocity or velocity of particle will depend upon both time as well as position. So this is half part of that statement. So this is also true, and particle velocity is also depends upon position as well, which is also true.
Okay, sir.
Any doubt in this section A?
No, sir. It's clear now.
Good. Section B is case-based study based on simple harmonic motion, in which first question is, which of the following is not characteristic of simple harmonic motion? It is periodic. Yes, it should be periodic. Option D, the acceleration of particle is directed towards mean position. But according to the formula, suppose you have simple pendulum. This is your mean position. and Bob is at any instant at this point. So it will be always attracted towards mean, or it will tend to move towards mean position. So you can say acceleration is directed towards mean position always. So this is incorrect statement related to simple harmonic motion. Second question, the equation of motion, simple harmonic motion is second derivative, that is acceleration, is equals to minus of omega square x. So it will be option A. Third question, which of the following expression does not represent simple harmonic motion? Just remember, trigonometric function will be periodic. Logarithmic function, exponential function will be non-periodic. And in periodic motion, that is in trigonometric, only sine function and cosine will be SHM. The rest of the whole term will be not SHM, but periodic. Also, in this sine and cos, it will be periodic only in case of linear power, or if there is superposition of two SHM having same angular velocity. So if you have y is equals to a sine omega t to the power n, so if n is equals to 1, then it will be SHM. Otherwise, it will never be SHM. Next, for superposition of two SHM, suppose y is equals to sine omega t and cos omega t. So this sum will be SHM since it having same angular velocity for both these two expressions. So we can say superposition of two SHM having same angular velocity will be SHM. Otherwise, it will be periodic but not SHM. So these are different property of particle or to be SHM or equation to be SHM. So in this part, option D will be incorrect since it having power 2, or there is product in between sine and cos. Is it clear?
Yes, sir.
Which of the following motion is not simple harmonic motion? Vertical motion of spring? Yes. Motion of simple pendulum? Yes. Motion of planet around the sun? It will be circular but not SHM. And oscillation of liquid in U-tube, it will be periodic as well as simple harmonic motion. Let's say this is U-tube. And initially, liquid is filled up to this point. So if you compress liquid along this direction, so it will raise up along this direction. So it will start oscillating up and down, up and down, up and down, like this. So it will be SHM. Is it clear?
Yes, sir.
Any doubt in this section?
No, sir.
Section C, show that acceleration of particle in SHM is proportional to its displacement from mean position. According to formula, y is equals to a times of sine omega t. Just differentiate it. You will get velocity dy over dt. So it will be equals to omega times a cos omega t. If you further differentiate it to get acceleration, or it will be equals to minus of omega square a sine omega t. This quantity is also displacement. So we can write a is equals to minus of omega square y, and acceleration is proportional to displacement with negative sign. Hence, we can say acceleration directly proportional to displacement, and it is directed towards mean position always. Is it clear?
Yes, sir.
Question number 10. We have spring mass system or tree arrangement. In first, there is only one spring. So time period will be 2 pi root under m by k. In second part, we have two spring connected in series. So according to the formula, 1 by k equivalent is equals to 1 by k1 plus 1 by k2. So it will be simply 2 by k, or k equivalent in series will be k by 2. So according to the formula, time period is equals to 2 pi root of m by k, and k we have k divided by 2. So you may write root 2 times 2 pi root of m by k. Similarly, third one is parallel combination. So according to formula, k equivalent is equals to k1 plus k2, which is simply 2k. So time period will be 2 pi root of m by k, which is 2k. So it will become 1 by root 2 times 2 pi root under m by k. Now in this part, this term is same in all three expressions. So if you take the ratio of T1, T2, and T3, you will get T1, T2, T3 is equals to, first one is 1, and second term we have root 2, and third term we have 1 by root 2. So this is your required expression you have to derive. Safullah, any doubt?
Sir, can you explain this again?
In first part, in this one, we have just single spring attached to any mass m. So according to the formula, it will be T is equals to 2 pi under root m by k. Is it clear?
Yes, sir, it is.
In second part, we have two spring connected in series. So according to the formula, series combination, 1 by k equivalent in series is equals to 1 by k1, 1 by k2. So it will become k by 2. Now, if you substitute this value in the formula of time period, so it will become 2 pi root under m by k, and k we have k by 2. So move this 2 out of this square root, so you'll get root 2 times of the rest of the term like this. Is it clear?
Yes, sir.
Similarly, in third part, which is in parallel combination, so it will become 2k. So if you substitute in this part, so 2 is in denominator, so move it to outside by taking root 2. So you're left with 2 pi root under m by k. Now just compare. We have same term in all of these three expressions. So on taking ratio, you will get 1 is to root 2 is to 1 by root 2. Is
Yes,
it
sir,
clear?
clear.
Good.
Clear, sir.
Question number 11. Velocity of sound under STP. STP means standard temperature pressure, where temperature will be 0 degrees Celsius and pressure will be 1 atm. So velocity of sound at this condition is 400 meter per second. What will be velocity when pressure changes to 2 atm without changing its temperature? I had defined you factors affecting velocity of sound. If you have to define for pressure dependency, just check whether the process is isothermal or non-isothermal. If it is isothermal, then velocity will be independent of pressure, we can say. Is it clear?
Yes, sir.
So in this part, since temperature is constant, so velocity will be independent of pressure. It means it will be same as 400 meter per second. But suppose if you have to calculate for the second part, so according to formula, V2 is equals to V1 is equals to gamma times nRT. And if you convert temperature in terms of degrees Celsius, so it will become 273 plus 0 degrees Celsius divided by mass m root under. For the second part, you'll get gamma R divided by m, and temperature is 273 plus 819 root under. Now just divide these two parts, V2 divided by V1. So rest of the thing will cancel out. So you'll get 273 divided by 273 plus 819 divided by 273 root under. So this part and this part will cancel out in one time. This part and this part will cancel out in 3 times. So you're left with 3 plus 1, 4. On taking square root, it will be 2 V2 divided by V1. So V2 will be 2 times of V1. That will be 800 meter per second. Is it clear?
Yes, sir.
Next, you have to define why and how Laplace corrected Newton's formula of velocity. According to Newton's assumption, velocity of sound is isothermal process. So in case of isothermal, beta will be equals to pressure. So on substituting their value, he got velocity of sound to be 280 meter per second, which is smaller as compared to velocity of sound in actual. Laplace corrected by taking propagation of sound as adiabatic process. So beta in terms of adiabatic will be gamma times p. On substituting their value, you got the required answer, that is 330 meter per second. I defined this particular question in your notes also. Okay, Saifullah?
Sorry, sir, I was not able to hear you.
This is directly from your notes, Laplace correction and Newton's formula of sound.
Yes, yes.
Okay. So next question is question number 13. A simple pendulum is hung in a stationary lift and its time period is t. Suppose this is lift and there is a ball or a body inside it. So if you accelerate this particular system, let's say some acceleration a. So initially this body will be experiencing a downward force due to gravity, but due to acceleration of system in upward direction, another force will develop into it, which is called pseudo force, which is due to acceleration of system. Is it clear?
Yes, sir.
So net force experienced by this body due to acceleration of system will be mass times gravity plus acceleration. So this quantity will be net acceleration of body. So using this concept of pseudo force, you may define what will be impact on time period. In first case, if lift is going with some uniform velocity of v. So in this case, acceleration will be 0. So there will be no impact of time period on time period. So time period will remain same as t. In the second part, if lift goes up with some acceleration a, so net acceleration in this case will become g plus a. And according to the formula, time period is equals to 2 pi root under L divided by net acceleration. So net acceleration in this case increases. So we can say time period decreases. And in third part, if lift goes down with the same acceleration A, so in this case, net acceleration will become G minus A. So net acceleration decreases, so time period must increases. Saifullah, is it clear?
Yes, sir.
Question number 14. We have equation of traveling wave. So coefficient of sine will be A. So in this part, amplitude is 0.005 meter. Coefficient of t is called omega. Omega we have 3 radian per second. Coefficient of x is k, which is 80 radian per meter. Now, according to the formula, amplitude of displacement, which is simply a, which is equals to 0.05 meter. Amplitude of velocity, if you differentiate this expression, you will get particle velocity as omega times of a cos omega t minus of kx. So this expression is called amplitude of particle velocity. So it will be omega times a. We have omega